Hi guys, welcome back. So today, I'm going. Last time when I left off, I was actually showing you how to basically look at which session are causing a responsible for locks inside of Oracle. So now I'm just gonna go into more details on what the database block is and basically how I/O reads inside of Oracle occurs. So basically, in terms of the database block, um, basically at the um, you have rows. The data is stored from the bottom up in Oracle. So that means that every transaction that's submitted is actually basically is being processed from the bottom from the bottom all the way to the top. So basically, you have the different rows being inserted inside that database block. And after that, you have some free space. These are not it's not mandatory to know these. But basically, when you get to this part, this is what you have to know. You have to be aware of what the ITL is, interest transaction list. Basically, that's just that's where the rows information is stored at the highest at the third highest level inside of the database block. And then you have to also be aware of the transaction header and basically just again these header sort of are the same essentially. So basically every time a row is inserted in Oracle, what happens is that information on that row is actually stored in the header. So basically, if you have an insert statement that's committed, that information is going to be stored here, in the different block headers. And then the ITL comes in with basically what it ensures that it ensures access to the headers and basically subsequently to the row data information. So ITL actually ties in more with these parameters, the percent, not the percent feed, but I'm gonna cover. Should be in the next one. Not this one. Okay, I'm gonna cover the ITL later on. It should be in the next two slides. So basically, what it works is you have instead of Oracle, right, you have these two percentages. You have the percent free and the percent used. So the percent free is this part. So the rows are inserted from the top. I mean from the bottom to the top. So typically what happens is that you leave yourself, you set this parameter percent free to basically the default in Oracle is 15% I think. And basically and the default 4% use is 40. So basically what happens is that you leave this space for a particular set of transactions, and those will be updates, potentially updates. But basically, again, it depends on what type of environment you have running. So here you would have insert and delete statements. These are the they make up the bulk of the data that's stored inside of the block. So when the information is brought gets all the way to the top. Basically, when it's near the percent, when it goes past the percent free, that basically you're alerted by Oracle, to basically again it's probably just gonna be a downgrade in your degradation in your performance. So this is an issue that one of the things you can research if you are experiencing really bad performance. If your users experience really bad performance, so you have percent free. So basically, you reserve this for as I've already said, and you also have this other parameter called percent used. So basically, what happens is that you set a I don't want to go into like what he's saying, but basically, again, so basically percent fee percent use is increased, it basically just takes the, as more transactions being committed, it's the this level rises, and then this is a result of a delete. So basically, when you get to this high level mark, basically here you would basically typically just issue a delete statement, and this is gonna bring down it's gonna bring down the data, the level of data back to back to something closer to the percent being used. And basically, the only time you can reinsert more data into a block is when the percent used, when the percent for the percentage is lower than the percent used. So basically, it's very simple. It's very simple in terms of the principles for percent used and percent free. Percent users, you can't, once you've committed a certain number of transactions, you can only insert more transactions if you delete the raw data to a level below the percent use percentage, and the percent free, you should only leave percent free for for update statements that you anticipate are going to occur on those blocks. And let me just make sure I review these so that I don't miss anything. Okay, that's what I was saying. So pretty much, this is just a cyclical process. You're gonna have the rows and the data, the raw data, the data or the rows inside of the block basically just go up and down depending on which operation is being committed. And basically you would only have a performance issues when you get to basically when if you have the one configuration for the percent free, and basically you don't have enough space for basically potential update statements. So that's one of the things you should look out for. So this is just an example of some how to set the percent free and the percent use in Opal. And again, as I've already told you, the default is 10%. I think it's 15%. It's either 10 or 15%. And for the percent free, the default percent use is 40%. So basically, you can create a you can place this parameter inside of a as you're creating a table, or if you're altering a table space, or also if you're creating an index. If you look at the syntax for creating an index, basically what you're doing here is you just let me show this right. So what you're doing, you create an index, you create any type of index. And basically what you do is you just specify percent free, and basically that's gonna be the level mark for your index. Again, the index is just it still has blocks, so it's gonna be the same. It's gonna be the same. The same concept with the data fluctuating back and forth based on the operations being placed inside that block. So this is how you would write it in a for an index. This is how you would write it for if you were performing an update if you want to modify it for a table space. Basically, you would just actually, before I get to this is so you can create an index and specify the percent free and the percent use. You can definitely do that. And you can also do the same thing. You can also specify these parameters for a create table. But the thing is that when you're creating a table, you would what you do is you would assign these parameters to a particular table space. So basically, and then basically you just again. So I'm trying to find. Yeah, so basically the parameters that you're setting would apply to the table space that you are that you're creating along with along with the table. Um, and basically again, the table space is just you set at the table space level because it's the it's the more of a again it's the that's what the object is gonna be stored. And so basically you set at that level so that the blocks for for the table objects, since they already have a table space, the table space will be responsible for monitoring those parameters. Um, um, just the the evaluating and the reconfiguration for those particular parameters. And here this is basically after you've already created a table and you configured you assign a table space to that for that object. What you can also do, you can also alter that table space to adjust these values if you wanted to. And then you would just put in the percent free. These are different parameters that you can put in for as you're altering your table space. And so now I'm gonna get into what an ITL is. So basically the way that it works is you have, again, this is the same architecture this is the same diagram for the database block. You have the rows being inserted from the bottom up. At the top you have the ITL and you have the different headers. But basically the way that it works is you have in the headers you have these two parameters, the init chance and minimum chance. So basically, what happens is that you can have a minimum. Again, the ITL is for the transactions. So the row one would match header one transaction one, at the header level. Row two would match header two transaction two. So basically, that's just how the transactions are kept. Transaction storage occurs inside of a database inside a database block. So basically, what this means is that so the minimum number of transactions that could be part of the ITL is part of the ITL ultimately the header is one. That's the minimum number of headers you can have, transaction headers, and the maximum is actually 255. So just think of if you have if you have basically the rows would would be 1 to 255, and then the maximum number of headers at the top would be 1 to 255. I mean, yeah, 1 to 255. And you can also just adjust these values as you see fit. I hope that I'm able to do it, because I show parameter. Actually, you know what? Select describe. What I'm looking for is not this, but basically there's a I think it's there's a table or a dictionary view or something along those lines that actually shows you what an init trans is, but I've actually not had to change my headers at all so far. So let me do this. Store object. Same thing. Function. Yeah, I probably won't be able to figure out now, but what I'll do is I will post the script for how to basically find the image trends. I've done it before, but again, this is one of the things that this is one of the solutions that you really think of, because it's really a problem. So I'll post a video, the text, the scripts for how to find your inner trends in my in discussion section of my YouTube channel. So just be on the lookout for that. And again, so it's pretty straightforward. So you have different sessions. I just throwing different records of rows, and basically, and you just have these rows that be mimicked by the ITL level, and you just have different slots being created, and therefore at the header at the very top, basically that the header can actually access the row that information, because it's directly it's directly above the ITL slot. So you just basically just gets the information from ITL slots, and that's how you have that's how the database, the queries can be servicing Oracle. And yeah, as I've just said, so basically yeah, so it's sessions, and again, just going back to your account, just again, when you're dealing with lock types, so it's all about which session has access comes to a database object first. So basically, session one would just hold on to header, if session one is actually just query row one, you will hold on to header number one, and basically, and then it's not going to be that header is not that header is not going to be released. The lock on the header is not going to be released until the user is able to commit that statement. Or again, I've gone over the different ways to basically just ensure that that contention, or to resolve contention issues. So. And in terms of latches, so basically latches and locks are fundamentally the same, but with latches they are more they do not allow for any other session to have access to the database object. So basically with latches it's basically complete exclusivity rights to a database object. And basically, but the good thing is that basically this only, because it's more of a it's more of a grab and hold on to a method. Basically it doesn't last for too long inside inside of it doesn't last for too long. So it actually be maybe for a second or two inside of Oracle, and then that latch is going to be released, and again the other person will be able to access that object. Whereas a lock is basically, even though you have access, other sessions can view that object, but they cannot make any modification to it. So, but with a latch, they cannot view that object, and they cannot access that object. And basically that's the big sticking point with the latch in Oracle. And again, as I've already told you before, latches and locks are very different processes. And then you have an NQ. An NQ it's actually fits in both categories. So it fits in the category of a lock, and it also fits in the category of a latch. So basically, what it does is it's just think of two sessions, right? And basically, again, there's no what actually regulates which session is able to write in which database object is the NQ, right? The NQ process. So what NQ does is it just basically it only allows for one session to have writing privileges on a database object, and then when that lock or latch is released, then the other section is able to do the same thing. So it just, again, as the definition says, it's just a way to basically ensure that only one session is able to make any modification to a database object. And with latches come in two different modes. One is the immediate mode, basically the server process actually requests access to your database object, right? And if the server process, if the configuration is for immediate mode for the latch, then basically the server process is gonna basically just continue. It's gonna even if that server process is denied access by another server process, then what's gonna happen is that it's gonna override that denial of that access denial and gain and basically be able to access that object. That's the immediate mode. Um, and also you also have a willing to wait mode. Willing to wait mode is basically if one server process already has access right to the database object, the other server process is just gonna it's gonna spin the wording will spin, as you guys can see here in the next bullet point. But it's just gonna spin in place. It's gonna spin around as it's waiting for the for that lock for that latch to be released on that object. So basically, it's just one mode ensures that your request is completed, and the other mode basically basically allows just gives some time to the other server processes to complete servicing of of a user's request. And so when you have that spinning, when the latch spins, as it's waiting for the server process to release the lock the latch on a database object. That period of waiting is actually referred to as a wait or a wait event. And basically, so again, another way another two other terms you can use um two other way you can refer to weights are just latch spin and latch sleep. Latch spin is basically when you have a the server process that's not being able to access that object just spin, and it just spin just perform spinning and just spin as it's waiting. And basically and then the other aspect of the wait is the sleep, the latch sleep. So basically, after the latch has spin long enough, let's say again it could be this is just an example of really a really bad you know like a really bad circumstance. So the latch sleep would actually just be when the server decides to go to sleep, because it's spent a lot of resources with the spinning and waiting for access right to this object. So basically the latch spins basically just again they can be recorded in they can be recorded again as I have here just in CPU time. And basically, so it's gonna just say basically just how much like how many the IO reads, for example, or just the processing time, basically. So yeah, it's just gonna basically latch spins are recording processing time, like how long it takes before for the processor inside of the processor on your system to basically to service the request. And again, that only makes sense because again what I'm trying to say here, and again it only makes sense because again what you're doing is even though you're spinning and you would think that nothing's taking place, it's just, but actually what you're doing is the latch is still, the server process relies on resources to be able to spin. So again, that's why the CPU time, that's why it's recording CPU time. And then also you have a latch sleep, and the latch sleep is actually just recording in wait events. So basically, as I've already told you, so the latch spin occurs, and then the latch, and then after the server process basically just kind of gives up on being able to access this object. It just goes to sleep, and that's what's officially known as a wait event. So a wait event is an extended an extended you wait for an extended period of time for access to a database object. And again, so again, so it's just the last one. The last part that I have is just the latch free events. So basically, this is a combination of the last spin and the last sleep. Um, and let me see what I have here. So latch free events. What I'm trying to say is latch sleep occur because of latch free events. So I think what I'm trying to say is the server process is able to go to sleep because um, it's because of the overwhelming amount of time is spent spinning and eating up resources, and that's what's referred to as the last few events. So again, again, I might be wrong on this, but I think last free and last spin, partisan process, and then the last sleep just occurs at the very end when the server process are giving up on accessing that object. So in terms of, so now I'm gonna cover the Oracle wait interface. So basically, what Oracle wait interface is, it's a way to just monitor the wait events inside of Oracle, to monitor these events in real time. So basically, what you have to do is, the first thing you need is to basically make sure that your and I still have my I still have my Windows, I still had an ongoing DM operation from the previous video. So what I'll do now is, so you need to have time statistics enabled, right? So what I'll do now is, let me check if I have time statistics enabled on my system. So I'm going to issue a command, and again, to enable time statistics, you just have to basically just make sure you have a default a true for your value, and basically by default this is the default value is true for the time statistic parameter. So let me do this. Show parameter time statistics. So it's true, right? So what I'll do now is basically, so time statistics is just it's just recording the timing for different operations inside Oracle. So I just check my time statistics, and so what I'll do now is, these are the different components, of the Oracle wait interface. I'm gonna put this to the side. You have these dynamic performance views. You have the V $system event, V $session event, V $session wait, V event name. These four components make up the Oracle wait interface, OWI. So basically, the V system event, you have wait events at the system level. The V session event, you have wait events at the session level, and they include the SID number. The V session wait events that are basically taking place in real time. They also include basically there's also a column for the SID number. And also you have V event name. These are just basically just general wait event information. Type of wait event, and also the ID number for that wait event. So what I'm going to do now is, let me see if I can do this. Let me do this. So what I'm going to do is, I am going to describe the session event. So basically, this is just, again, it's at the SID level. So you have the SID, the event name, the time that basically like basically how long it's taking. It's it's taking for that. How, for how long the wait has been taking place, and then so basically you would just query these different columns based on what you just you're looking for. And then you also have you also have this system event. And again, so always remember to put the $, at the front. So just on a side note, the dictionary views typically have a DBA or a prefix with a DBA or a user or all. That's a prefix for that dictionary views, and for dynamic performance views, the $. So let me do this. Describe the dollar session underscore wait. So basically, these are just the columns for these four performance views, and then describe the dollar event underscore name. Okay. So what I'm gonna do is, so in one of my, I have a demo coming up. I'm gonna show you how to actually use this in real life to, to basically just assess what's going on with your, with the weights, in different sections inside of Oracle. So let me do this. Put this to the side. Okay. So basically, what weight events are, they can also be referred to as bottlenecks. So basically, again, the definition is just you have a server process and they cannot access a database object, and so that waiting, the period of time while they're waiting, that's recorded. Number one is that's being recorded, and that also that's referred to as a wait event. That period of time while the server process is waiting for another server process to be done with the database object. So the different types of wait events you have in Oracle, you have a DB file sequential read wait event. Basically, this actually deals more with indexes, and basically what you have is so typically the way that it works is you have blocks. So the architecture of a inside Oracle is you have blocks, and they are contiguous blocks, and then that's how you eventually get to have an extent. So basically, so when I say sequential the sequential read for a wait event, that means that basically you just have a wait event for the reading of those contiguous blocks. So that's the DB file sequential read. You associate mostly with the index, because that's again, if you think of a bitchin index, you just have the way that the index is actually the way that bitchin index actually work is you're parsing out different low values to sort of allow for visibility and accessibility. And in doing this, what you're doing is you're creating contiguous blocks. So let's say you create an index on the table on the objects where you were looking up person's name. Basically, you can actually arrange it alphabetically, and basically you would just have reading. You would have the reading of those blocks, in a contiguous fashion. And that's the reason why, again, this is most associated with an index. And also you have DB file scatter read. This is more for if you're dealing with a full table scan. Just think of it's a select statement where basically you just coin in from any table, and there's no word clause. So basically you have the data is actually scattered all over the place inside of that object. And basically, again, there's no contiguous block again, because you don't have an index on that object. So the V's are actually just, you know, they're not being controlled. So and because it can be they're not being controlled, they cannot they cannot be read into memory in a contiguous fashion. And also you have a direct path read or write. So basically, again, the word direct actually comes in with when you're performing export and import operations. Basically, it's just a way to bypass the SGA and just have direct you know, access to, you know, the memory, right? Memory area. So um, and also that's just what a word event would be for a direct path read or write. Um, and then also basically you would have a what event direct path read or write event when you have a heavy you have heavy sort operations, and basically you don't when you don't have a when you don't have memory enough memory space to store those to store those sort operations, and they are actually basically just written into temporary table spaces or disk. Basically, that's just again. This is just you know, the way rent would be basically more for, you know, the storing of these sort operations in these onto the disk, onto the, you know, temporary table spaces for future reads. And basically it's just having a direct path access to those to that to those, you know, blocks. So that's the way event for it at that level, at the disk level slash temporary space level. Basically it's just you know, it's referred to as a direct path read write. Um, and also you have, again, this is another word event, is the enqueue word event. Again, as I've already gone over earlier, obviously the enqueue process is part of both the lock and latch process, and basically it's just again, it's a way to ensure that no two server processes can make any a modification or a change to a database object at the same time, and basically that you just have a wait event as, you know, for one of the server processes, you know, basically, you know, for that, for access to the database object. And also you have a buffer busy wait. Basically this is just a wait for let me show you this right. This is just a wait for the database buffer cache. So basically, again, the buffer cache is an example of a simple object. So basically, you only have the internal structure for database for the buffer cache is just blocks. So basically, that means that if you have a wait, that would be more of a, you know, a server process just waiting for one of the blocks, one of the locks on the buffer block to be released, so that then they can so that then that server process can have access to that same that same blocks for you know, to service the user request. And then basically how to resolve this is to just basically you can do some SQL tuning. Basically you can one of the ways you can do this is to you know, basically just you can make the reading, you can have the server, you can tune the Opal software so that the log writer, no, so that the database writer actually is you know, works, that is actually is performs more of the writes from the buffer cache to the data files. So that's just an example of how you can tune the SQL statement and basically and avoid having you know, you know, to deal with a buffer busy wait wait event. And also you have a library cache pen. So basically this is just a again, the library cache is stores actually I shouldn't say that, but yeah, it's stored, compiled, and parsed SQL statements. So basically, what the library cache pin does is just ensure that that server processes, not ensures but prevents other server processes from accessing a a parsed or compiled SQL statement. Um, let me make sure it's right. Yeah. So here streaks. So here's okay, exactly. So this is what I'm trying to say. So this is the most important part with in dealing with library cache. And so you have a so basically this happens because you have a compiling or parsing that's in progress. So either the compiling compiling process in progress, or the a sub process that has exclusive rights on that on this object for the other for another sub object to not be able to view it or to make any modification to it. So again, so that's just again to just round this all up. These are just the different word events that you have that you that are part of that are part of Oracle software. So what I'm gonna do now is next one. Okay, this is what I was trying to say. So what I will do is I've actually already demoed this. What I'm gonna do is I'm gonna recreate a scenario that I had earlier on, and let me make sure I have this right. So I'm gonna again. The scenario I had early on was I had two Stitch user accounts up and running, and I had an OE user account also logged in. So let me just make sure to remember just remember which one was which. Show user. This one has VOE. There you go. So this is sys, and this is OE. So the scenario that I had before was I was running an update statement, update set, okay, and let me do this, update set 160. Okay, there you go. So I had a this is the log contention that the example of a log process that I was going over earlier. On which I went over earlier. So what I'll do now is and let me do this. Let me minimize. I wish this SQL plus Mini was more flexible, but apparently it's not. So let me do this. Describe the $session. So I just need to make sure figure out which session is again I already know that I think last time I checked this one was 145, this was 22, and 140 again. And obviously 145 is the reason why there's a holding there's a contention on my database object. So let me do this. So I described the session event. So let me query and get more information on what's going on. Event time waited underscore micro. Let me see what else I need. And let me see if wait class is also going to be important from the session underscore event. Yeah, that's way too much information. That's definitely too much information. Let me do this. For SID is equals to I wish set line size. Okay. And I cannot. I need to know how. I need to. I hate setting up the line size for this thing. I can't figure it out. Okay, this is somewhat better. So basically, here it's just showing me my again. I'm already calling SID 22. What's it? What from where I have word. And SID is equals to 145. Not N, but O. There you go. I'm gonna set line size 300. Alright. This is my my Achilles heel in terms of database administration. So you have basically it's just showing you the different wait event types, different wait events. I mean, and how long the waits have gone on for in microseconds. So pretty much, again, this is what I experienced earlier, the rollout retention. And basically, and again, so in terms of the VDAR session event, this is actually, which one am I trying? VDAR session, yeah. So, yeah, VDAR session event. So again, this is just, these are just the different, the wait events that are taking place in these two sessions. And again, you might be asking yourself, so it's okay, so what do I do with it? Sorry, so it's not only this parameter that you'll be using, so you also be not only this performance you'll be using, you also be using a this is one that I think is more useful. Oh man, set line size. Okay, let me do this. I have my event, so let me select the event. Time weighted micro. I total weight, but what else do I need? Got the event generally. Let me see if this is going to be enough. The system underscore event. This is for the just to look at the word events. From the other system. Starting with all the way to the system level. Or from the system level. I mean, so pretty much you have again. So this is the reason why I hesitate from running this query in the first place. You get a reading of the word events since the database hit the ground and started running. So pretty much even though the session event like I'm able to I know what's going on here, and again, I started routing against earlier, but this is what you're pretty much stuck with. System event is, again, if you have a database that's been going for, running for, a number of years, then querying the VDAO system event is gonna take a really long time for that query to complete. So what I do now is, let me also check out what my session width. What's going on inside the session weight? So session weight. So here again I have, let me calling, select SID. What do I need? State. Wait. Micro. And again, this is the because everything is recording in microseconds, so you just have to, potentially do some conversion. And let me do this from v $session underscore wait. Okay, how many rows do I have? 28. Set line size. I had 20 before. Let me do 45. 45. There you go. See, I just got lucky on this one. So, basically here you have just wait events for the session level, right? So basically you have, again, it's showing you that the SID number 26 just waited for for a short time, and you just tell you just how long the waits, how long the wait events lasted. Session of wait. There you go. Okay. So basically, this is just how you're reviewing the SID and what's going on internally with with the different sessions. Then let me do this, and then the last one. This one should be the regular one. So it's $5v event underscore name. So select name event ID event number from the event underscore name again. So okay, where so this is again, so these broad performance performance views, they just give you so much information. You just have to, that's why these two are the best, because the most read session and session event and session wait. Let me see if I can just try read session underscore event. So let me do this. Well, I know if I go to select star, it's probably gonna be like something that's it's not gonna be pretty. It's not gonna be. I'm not gonna have a pretty result set. But let me do this. Total wait. I'm trying to just make use of these performance views, and since they're part of ODR, you definitely be using them. But I just need to give you a clear sense of what you can actually accomplish with them. Event unrated session underscore event. I have 100 before, so let me do 150. Let me try. Yeah, so pretty much it just shows you what what the wait event is, and which session that wait event occurred on, And again, just pay attention to the different names. Again, SQLnet. That's actually it's just referring to SQL Plus. Um, and basically again, so SQLnet, SQL and client are just again SQL Plus. Substitute for SQL Plus. So then there's the last scenario that I'm going to show you. And what I'm trying to think of is, I'm gonna pause here because I had more to do than just this. I was gonna show you how to figure out which how to best use the OWI to resolve you know session concerns from different users on the fly. So thanks a lot for watching, and I'll pick it up from this point next time. Thank you.